Hey guys, welcome to another episode of Intro to C++. Um, so if you guys are following along from the previous tutorial, which was data types, you would want to start and download, the this thing. And did I even upload it? No, I did not. Let's do that right now. That I did. Okay, save all. So, okay. So we add it, commit, intro to C++, tutorial 2. Wow, I thought I did this last time, right after, but I guess not. What did it call it? Yeah, data types and push. Okay, let's refresh this. And there we go. Okay, so you would want to start from data types or not if you don't want to. So let's go to it. Yeah. So let's go here and do that. Okay. So last time we learned about data types. And I have a correction to make. This is not the exponent operator. It is the XOR bitwise operator, which is completely different than what I was saying. So if you want to do exponents, you would actually have to include a library or make your own function to do that. And maybe we will do that later. But yeah. Okay, so let's go here and let's make a new project. And let's name this operators operators and constants. Okay, and let's set this as the startup project, and we are going to add a new item and a C++ file to it, and we're going to get our header just like we did last time. And okay. So let's talk about constants first. What are constants? Well, constants are values or variables that hold a value that does not change over time. It is the same value throughout the whole program. Okay, so variable that contains same value as startup and cannot be changed. And why do we need these? So how do we're gonna to declare one? All we have to do is just say const int, and this will be a constant int variable. Okay, and you should always set it to be like, let's say we're making a library and we want to make the pi. So actually it's not an integer, it should be a float. So we created this variable called pi, and we know that pi will never change because it's the same number over and over again, 3.14 something something. Let's actually look for it. What is pi? Not Pixar. Oh, you stop at pi. So it is this big long number. So let's just copy that right there. Or can we copy this? Think so? No. Maybe. Yes. And let's paste it right in there. So now we have our pi value, and we want to make this a constant so we don't accidentally change it throughout our whole program. So make variables, I guess, constant if they are not meant to change over time. Another example would be if we have, if we have a maximum number of students that we can hold in our program. Let's say we have a server or something, we can have a constant value of, I don't know, max num people, and that would be like, I don't know, maybe 100, and this number will never change. This will be the same, and we would compare against it as we get more people and whatnot. Okay, so that is that for constants. Now, if we try to change it here, let's say I want it to be 12 now for some reason, we can't. It gives us an error, and it says may constant float pi, and that's the number, make variable constant blah blah, that's our this. The last thing says error. Expression must be a modifiable value. So you can't modify a constant. Now if we do this and then we can modify it, but we don't want to. Okay, so that's the good thing about those. What else? I think that's pretty much it for that. Now, operators. Operators we have seen before. Okay. And they are, plus, minus, times, division, modulus. These are arithmetic operators like we went through last time. And then we have other types of operators like plus equals, minus equals, times equals, divided by equals, not equals, and equals, or equals. So for that I should also do and, or, XOR, not. So these are bitwise operators. These are pretty much the same as these and these, just with the equal sign. So like we said before, this is the same thing as this. Okay? And then we have also some of the ones, and, for these are relational. We have or, we have not equals, equals. So let's put right here, and, or, not equals, equals. We also have greater, or I mean less than, greater than, and then we also have these, which I should put down here. Okay, and this is and, or, XOR, not, wait, think this one is like that for the bitwise operators. This we'll be dealing with maybe later, not today, because it's more advanced stuff, and this is used with, bits to change or, modify a value through their bits and bytes. But we'll be using these a whole lot. Okay? Are these relational or conditional? I don't remember, but let's say conditional. Okay. So how would we use these? Okay. So let's say we have A. Let's make it equal 10. And then we have B. And let's make it equal, I don't know, 11. So we use those operators if we're trying to compare something. And the way we do that is by if statements. So we're going to compare A and B to either be true or false. So if we do if A is greater than 10 and B is less than, I don't know, 10, then we are going to print something there. And let's include over here our, let's do the stdio. And we'll do the printf. And we'll say A greater than 10 and B less than 10. So anything, if the statement, it's not separated, above is true, then we run this code. And otherwise, if it is not true, then we run this. Okay? So we'll just say printf A is actually greater than 10. Let's say greater or equal to 10. And B is greater than 10. Less than or equal to here. Greater than 10. Or let's just say false. And let's just say true here. So if this statement or these two statements, because there's two, because we are comparing this and this. So if when we have an AND, when we have a double AND, we both conditions have to be true. So in this case, this condition is false, and this condition is false. So this whole thing is going to be false if we run it. Okay. And yes, it is false. Sweet. Now what if we change this to 20 and that's it. So now this one is true because A is greater than 10, but B is actually less. B is not less than 10. B is greater than 10. So this one is true, but this one is false. So this is still going to be false because they both have to be true. And we can run it again and see that we still get false. So now if we just put 5 on B and compile it, we'll get true because we'll be here because these both statements are true. Now, if we do the same thing, but instead of using AND, we'll use OR, and we'll have it the same as we had it. So they're both 10. Well, actually, this one was 11. Here, they're both false still. So we're still going to see false on the second one. But if we change this to 20, then we should be here in true because only one of these conditions has to be true. So it's either A or B have to be true. So since A is greater than 10, but B is actually greater than 10 too, it's still going to be true because one of those conditions was true. And we can see that right here. Okay, so now notice that when I print stuff, everything is compact, everything is placed together right after the other. We have several things we can do to format this string a little bit better. And I'm going to write it up here. Okay, formatting strings. So the first one is \n. This one, what it does, it creates a new line. So instead of being on the same line, it goes down once. /r, it's return key, pretty much. It just drops one, but it doesn't go all the way to the end, I don't think. And the second one is \t. which is tab. You can actually tab your strings apart. Another one, those are the only ones I use, I think. Oh, wait, no. If you want to do a backslash, you do that. That is backslash. If you want to do quotations, you do this, and then this. If you want to do single quotes, you do that. What else? There used to be one where you can do that, I think, or something like that, and it'll beep, but that is something else. Now, those are the ones that you really need to know. So let's say we don't want these to be linked with the other one. We will put a backslash n at the end. So when it's done, it'll just go to the next line. And you can see the effect. Okay. What else do we talk about? So, for if statements, you can also do else if, and then have another if statement right here. So maybe we want to check the opposite or something else about it. Maybe when B is true. Let me just say B is true. And we'll say A is true. And then right here we'll say none. Or just false. So when we run it, we'll say A is true. But if you put it like this, only one, this is going to be one whole block. Well, there's 3 blocks of code, but it's considered to be one. You only check once. So like, let's say you're here, you check. If this is true and you print this, then you're not going to check any of these. If this is false and this is true, you're not going to check this. So just something to note, because notice that this one is true because A is greater than 10, and this one is true because B is greater than 10. So these two are true conditions, and they should both be firing, but since they're all connected with this else statement, only the first one, since both are true, is going to run like you saw earlier. See, only A is true right here. But if we, do this, A and B is true, actually. So just something to keep in mind when you're using, when you're using these if, else statements. And you can have as many as you want, as many if statements as you want. You can have nested if statements, if here, else, whatever. Notice that if you have multiple lines of code that you want to run for each statement, if statements, you have to encapsulate your block of code in braces. But if you only have one, you can do this. Okay? So this is valid completely, and it's not going to crash anything. It's only saying that, okay, we got one line of code for this else if, but we might have multiple lines here, and that's why we have our, braces. Another thing about coding that I didn't go over on the beginning is formatting. Formatting is very important. You want your code to be as readable, as clean as possible. And there's different people that like to code like this. And personally, I do not like it because for me, it makes everything harder to read. Yeah, it might be compact, but everything is just harder to read now, for me at least. I don't like this way. You can develop your own way of formatting, but I usually like to make sure that these two match. So I just put them on the same line because it's much easier for you to know if something is out of order when you have it like this than if you have it like this. Because here it's like, I mean, nowadays the if you have a good, um, IDE, it'll tell you, but before you didn't have that luxury. You didn't have this where it how do you call it? Where you can look for whatever you want. You didn't have these colorful stuff. Everything just was black and white. So it was a lot different back then, but I still like doing this because it just makes a lot more sense and it's more readable to me. If you like the other way, go ahead. By all means, do it. But most of the people that I've known like it this way. So that's that. I know I wanted to go over more stuff, but okay, let's do one more. Not with if statements, but let's look at something we call arrays. And this will be the last thing. So what are arrays? Originally, you could only store one single data in a variable. So let's say we have int var, well, maybe not var, because it's probably a reserved word, variable, and we can only store one of these, one value can only be stored in a variable. With arrays, you can store multiple types, or not types, multiple values of the same type. So to do this, we just say, let's say our array. You have to do these. I think it's kind of hard for you guys to see. I'm sorry. We have these brackets, and here you can either put the, if you're not initializing it here, or yeah, whatever. You don't have to well, you should initialize it here, but this one is optional. Let's say you don't know how many you want, how many values you want, and you can do it like this: 1, 2, 3, 4, 5. So we'll have 4. We have 4 elements, or actually 5 elements, but we start from 0 all the way to 4. So this guy is index 0, 1, 2, 3, 4. So we have 5 elements, and they start from index of 0 to index of 5 minus 1. Okay? So to access one of these numbers here, we do, let's say that. We just do that. We get our variable, and instead of these brackets, we tell it what the index we want to extract from it, and that'll be number 3. So if we do printf, and this one's going to be new for you guys because we're actually going to be formatting this string. So this is our array, and here we're going to do that, and you can see that array at the index of 2 is actually 3, the value 3. So think of an array as a container where you can have multiple objects, not objects, but values of the same type, which are all integers here. So you can make this floats, well, not floats, but float array, and you'll have floats here. So instead of saying %d, you do %f, and that is going to do, float values. If you want to only have 2 trailing zeros, you do 0.2 or 0.02f, and we'll only see 2 zeros at the end. This lets us format our string with whatever variables we place here. So whenever we want to reference a variable that's here, we do %. And then if it's a integer, we do %d. If it's a float, %f. If it's a string, %s. And if it's a character, I believe it's %c. Okay. And these have to be matched, like the order you call these in have to be matched on the order that you put them in here. Okay. So let's introduce something else. Let's learn how to print every single value that we have in here. We have something called a for loop. This, I didn't want to get into these, but why not? So this is called a for loop, and it takes 3 parameters like this. So we want to say the starting point and the conditional value here, and then increment here. So we'll do int I equals 0 because we want to start at the index of 0, which is the first element here, 1. And we want to go until I is less than 5. Because remember, the last index is 5 minus 1, which is 4. So we want to increase I until I is less than 5, which is 4. And then we do I plus plus. Now, I haven't gone over what I plus plus is. I plus plus is the same as I plus equals 1, which is the same as I equals I plus 1. So all of these are the same. There's also another one called which is I plus plus I. And we'll talk about this more later. So now instead of saying 2 here, we just pass I right there, and we'll print out each value, 1, 2, 3, 4, and 5. And we can also do it a different way. We can go backwards. So we want to start at 4 and then keep going until I is not 0. And then we'll just minus. Well, yeah. Until I equals 0. No, that's a dang it. Okay, it's greater than -1. Okay, that works. So here we did it backwards. 5, 4, 3, 2, 1. So we start at 4, which is this, and then we decrease it every time we print something. And then when I is greater than -1, which is 0, we print it and then we stop. So that is a for loop. This lets you iterate through arrays to either place in values or print out values to the screen like we just did. What else? I think that's it. That should be it for this lesson. So we learned about constant variables. These are variables that cannot change its value. So once they are set, that is it. We learned about arithmetic operations. We learned a little bit about bitwise operations, but not really, because that is a more advanced um, lesson. We learned about conditional operators, if, or I mean, and, or, not, not equals, equals, less than, greater than, and then we have them right here. This is plus equals, minus equals, times equals, divided by equals, not equals, and equals, or equals, less than equals, greater than or equals. We learned how to format strings. Sorry. So we can add a new line, return to the other line, which is kind of like this one. Then we do tab. We learn how to do a backslash, quotation marks, doubles, and single quotation marks. We learned about if statements, else if statements, and arrays, and for loops, and how to print each element of an array. There's another way you can actually do this, which would be like this. And to initialize it, you just do that, and it knows that every element in this array is going to be 0. So if we change this to array 1 and we print that, we're just going to be seeing zeros. So this is another way to declare and initialize 5 elements to 0 of an array. Okay, I hope you guys had fun. I know I did. If you guys would like to subscribe to my channel if you liked it, if you want to see the code up here, if you are having problems, or if you want to follow along, don't forget to go into this link, which will be in the description. And yes, I'll upload this one right after I get finished with this. And yeah, hope you guys had have a good time. Bye.